Let's compare what Feynman said to the scientific method we'll be following in this course.
His video started by telling us to make a guess.
We can call this the hypothesis for what we would like to study.
Then he said to compute the consequences of our guess.
In other words, make predictions based on our hypothesis.
Then we see if our predictions agree with the real world.
Conducting experimental tests.
And if the predictions and experimental test results agree,
that confirms our hypothesis. Otherwise, the original hypothesis would be falsified.
But haven't you realized? Feynman missed a step before the hypothesis.
Good catch, Curio. We make our guess based on observation. Observations are records of information about reality that we have received through our senses. In principle, we want to record observations with as few biases and as many details as possible.
In other words, observations are statements of the world recorded through the careful use of the observer's senses.
Exactly. It's also important to note that observation statements are isolated descriptions of what we have observed at a particular time and place.
That makes sense because as an observer, I can neither be in multiple places simultaneously nor observe a phenomenon forever.
Let's take a look at some examples of scientific observations. At 1:54 UTC on 6th June 2012, Venus appeared at this certain position transiting the Sun when viewed from Tempe, Arizona in the United States.
I can see how the observation includes many details, such as when and from where Venus was observed. But in science, we may not be satisfied with merely making observations. We would like to turn them into scientific knowledge.
From our observation of Venus, we might propose a law that all planets in our solar system revolve around the Sun in elliptical orbits. We call this Kepler's first law. Another observation is that a fully bloomed sunflower faces east despite the setting sun in the west on an autumn day.
Really? I thought sunflowers were known for their daily dance following the sun from east to west to maximize photosynthesis.
This is why time and place in our observations are important. As sunflowers fully bloom and grow heavier with seeds in autumn, they will permanently face east to conserve their energy.
Wow, laws and theories are quite different from observation statements.
They sure are. Observation statements are about what happens at a particular time and place. But laws and theories should be universal in the sense that they describe all phenomena of the same category at all times and all places.
So from our example, all sunflowers should permanently face east when fully bloomed, whether they're in Hong Kong or Hawaii.